it's amazing to have you here. Well, in this tutorial, I'm going to show you how to create a grid of arcs, right? So a grid of arcs. What is an arc? Well, an arc is a piece of a circle, right? And this visual system that I've created here, this flexible visual system basically combines so many important and very valuable aspects of creative coding. We will work with a nested for loop. We will work with conditional statements, with waves, the conversion of variable types, and of course with arcs, which are pretty amazing geometric shapes that we can use in many different use cases. So I'm really looking forward for this. Let's kick this off and let's get started. So before we start writing the code, I would like to have a closer look at what arcs are and how we can use them in processing. So basically this is the result we want to achieve, right? This is a grid of 4x4 tiles which have arcs in them, right? And in processing, there's this arc function, which we can use to basically display pieces of circles. So as you already know, we have a function called ellipse or a function called circle, which display circles or ellipses, right? And these shapes always have 360 degrees. But with the arc functions, we can display pieces of these circles, just like this one with 90 degrees, or this one with 180 degrees, or this one with 270 degrees. What we want here for this tutorial are quarter circles with 90 degrees. One of the challenges we will face throughout the tutorial is the question how to position these arcs appropriately to make them, fit into a tile, right? So that's not too difficult, but I want to point out that inside of these 4 tiles we will use in this system, the center position of the ellipses varies in each tile. So here it is at the top left, here it is at the top right. Here the center position of the ellipse, or basically of the arc, is the bottom right, and here it is the bottom left of the tile. These are the 4 tiles we want to create in this tutorial. Well, basically we are going to create a 5th tile as well, which is, a red square, but this won't be a problem at all. So let's dive into the code. Okay, so now here we are. This is the code editor. So what you can see here is a very basic setup of a sketch, right? So I've got 2 colors defined. This is black and this is red, right? So always when I work with 2 colors, and I mostly do so, then I define 2 different variables. One is for defining the background color, and the other one is defining the foreground color, right? And here I've set the size of the sketch to 900 × 900 pixels, which is the standard format I use. And here I fill the background with black. Okay, so let's define the fill color of the whole thing by saying fill FG, and let's deactivate the stroke for any geometry. Now I will create 4 variables. The first one defines the number of tiles on the x-axis. Float tiles x equals to 4. The second variable is called tiles y, and I will set this to 4 as well, but in this case I can replace 4 with tiles x. So later on when I want to change the system, all I have to do is, changing this one number here. And then I will create another floating point value called tile w. And this is basically the width of one of these tiles, right? Tile w is equal to width. So the width of the whole format divided by tiles x. So this basically stores the width of the tile, right? And I will create the same variable for the height. Tile h equals to height divided by tiles y, right? And now I have all variables set to get started to write the grid system. Now let's create the nested for loop. For int x equals to tiles, 0, and then x is smaller than tiles x, semicolon, and then x plus plus. I know this is a little bit, strange for beginners to write a for loop, but this is basically, this repeats over and over again. A for loop is something that you will always use in creative coding, right? And this is something I did probably thousands of times. Okay, so let's create the other for loop inside of the first for loop. Int y equals to 0, semicolon, y is smaller than tiles y, right? And then y plus plus, parentheses, curly brackets, and here we are. So now let's create the two variables that define the x and y position of the tile, right? Float pos x, float position x equals to tile w times x, and float pos y equals to tile h times y. Whew. Okay, that worked. And now I can use those variables to distribute the elements on the grid. Let's see how that works. So first of all, we use the push matrix function to create a new matrix, and pop matrix to close that matrix again. And then I will use the translate function to translate the matrix to the appropriate spot. So, pos x, comma, pos y. Right? So let's see if that worked. Let's create a very simple ellipse here and see if I did everything right. So the x and the y position don't have to be set in the ellipse because we are already translating the whole coordinate system with the translate function. And then I will set the size of this ellipse to 50 times 50 pixels. Let's see if that worked. Yes, it worked, right? So of course these ellipses are now positioned in a little bit weird way. You know, we are just putting them to the top left spot inside of the tile, but we don't have to worry about this now. All I wanted to have is this result to get started to write the appropriate arc functions to display the tiles of, or to display the quarter circles inside of the grid. Okay, now let's convert the ellipses into arcs. So what we have to do for that is we have to change the name of the function from ellipse to arc, and I will put tile w and tile h into the parameters for the size. And the arc function receives two more parameters. The first one defines where the arc starts, and the second one defines where the arc ends. And because by default processing works with radians values, I always use the radians function to convert degree values into radians. Let's see how that looks like. So radians 0, comma, radians 90. Right? And when I hit the run button, I will get this result. Pretty cool, huh? So all I have to do now is to multiply the width and the height by 2, because that will put the tile or the arc into the, or it will just scale the arc into the appropriate size. Now I will create the second tile by copy pasting the arc function here, putting it into a second line, and commenting out the first line. So I will get one arc, which is basically, this is just a copy of the function above. And what I have to do here is I have to add 90 degrees to both values. And this will give me this result, right? So this is another tile, but as you can see, there's a little problem here. The tile is not at the right position, right? And I can fix that by putting tile W into the into the X position of that tile. And now I can just repeat that process twice to get the other tiles, right? I will again here comment that line out, and I will, add 180 degrees to both values, 270, and let's see how that looks like. Yeah, so now here is a tile at the bottom missing, or a line at the bottom missing. So what I have to do here is to put tile H into the Y position, right? So nice, that works pretty well, right? Let's take the function again and create another arc. This is the last one, and I will again add 270 degrees to that first or to the fifth parameter, and 360 degrees to this sixth parameter. Okay, so here we are. All I have to do now is to recalculate the X position. I have to, I want to shift the whole system to the left, and that's why I have to subtract tile W from the X axis, which means that I will have to put a 0 in here. And here we are. Now we have all the tiles that we need to develop that system. Now it's time to write the logic of the whole system. So as I showed you in the beginning, the original visual is controlled by a wave. But just to test if everything works well, I will for now I will work with random values, and later on we will go over to the wave thing. Okay, so let's create a selector integer. Well, an integer called selector, and this is basically the variable that decides which tile should be picked. Okay, and let's say the selector is equal to int, which is a function to convert a floating point value into an integer, and random 5. This is a random function which generates a random value between 0 and 5, and the int function will convert this to an integer. So this will be a pure integer value, right? It will decide between 0, 1, 2, 3, and 4. And that's what we need here. So let's write the conditional logic for the system. So if selector is equal to 0, then pick the first arc. Okay, so else if selector is equal to 1, pick the second arc. And now I can just copy paste that code here and put it down here. So if selector is equal to 2 and 3, let's take that function, put it in here, and let's take that function and put it in here. So I have a system now which now decides between these 4 shapes. And as I said in the beginning, there will also be a rectangle, which is pure red, right? So instead of creating an arc, I will create a rect. Position is 0.0. The width and the height are tile W and tile H. And, wish me luck that this works. I think it should work. So one thing, before I run the code here, one thing I want to explain is that, this function will never return 5, right? Because it just floors these values. The int function floors values. That means it just, when you've got something like 0.9, it will floor that value to 0. And that why this int or this variable called selector will never reach 5. So in case of 0, it will create this arc. In case of 1, it creates this arc. In case of 2, this arc. In case of 3, this arc. And in case of 4, it will create that rectangle. Let's see if that works. Yes, it looks pretty amazing, right? Yes, this is a great moment. I'm so happy about this. Yeah, it works, right? It works. Now we can think about the logic of the wave. Let me quickly clean up the code here. I will hit Command T to do so. Well, Command T is very helpful, right? So this was the code before, and when I hit Command T, it just auto indents and cleans up the code. It makes it a little bit more readable. This is an automatic algorithm that just takes the whole code and cleans it up. That's very, very helpful. So Command T is a powerful shortcut. So, oops, this is the position, or this is the piece of code that defines how we select these tiles, right? So what if we want to have a wave instead of randomness making that decision? Let's create a wave here. Let's call this variable wave, and let's say sin parentheses. So the sign function, maybe you know that, creates a value between -1 and 1. And as you hopefully know, I always use the radians function to basically work with degree values in here. So radians frame count. This will create a wave that moves between -1 and 1. And which is driven by the frame count. So one whole iteration of that will be reached when the frame count is 360, which is pretty helpful to create perfect loops. Now I have to map the value from -1 and 1 to 0 and 5. So let's create another variable called float mapped wave is a good name, I think. Mapped wave equals to map wave, and the map function receives 5 arguments. The first one is the value we want to map, and then the second and the third argument define the range or the original range of values, and the fourth and the fifth argument define the new range of values that we want to map to, right? So the original range is -1 and 1, and the new range is 0 and 5, right? So now I can take that take that value or this variable here and put it into the selector. And when I hit the run button, I get this result. So the wave goes through all of the tiles here, right? And yeah, just goes from 0 to 5 to select one of the tiles here in the system. Okay, so we are very, very far already. So the question is, how do we get a little bit of variation into each frame, right? So at the moment, every frame looks the same way, right? So they're always the same tiles inside of each frame. But if we want to, create some variation here, we have to adjust, or we have to modify the driver of the wave. Let's say we add x times 10 to the frame count and y times 10, right? So I just multiply these values because I just have just a few tiles, and only x would result in a very small value, which wouldn't really make a difference. And that's why I'm just multiplying these values here. So let's see how that looks like. Wow, right? Basically that's the result I wanted to have in the beginning, right? So now the wave varies the tiles based, now the system just varies the tiles in each frame based on that wave motion. And that's exactly what I wanted to achieve in this tutorial, right? So that's exactly the result I wanted to achieve. I really enjoyed recording this tutorial. I hope you enjoyed it too. Yeah, let me know in the comments what you think. And I'm very much looking forward to see you and in the next video, and enjoy. Don't forget to subscribe and like the video. Have a great day. See you soon. Bye.